Okay, now we're going to continue with the exercises. Last time we solved application 6 from the course and we started with the exercises and exercise 1 in particular. Today we're going to continue, in this session we're going to continue with other exercises. In exercise 2 we focus on connecting a multimeter. By the way, I got something now. I have here a multimeter that I got for my house. A multimeter always has the 3 entries, the V, A, and the COM, and we can choose on the dial. This one here just has 2 because it functions as an ammeter in a different way, and we can choose on the dial the connection or the type of measuring that we need. Okay? Now, in this application, in this application, we just have the multimeter with the 3 entries or the 3 outlets, A, V, and COM. It is connected to a simple circuit made up of a generator and a lamp. In the question we have, in each figure of the document, we have 4 figures here, by the way. Now you can see one. On the following pages we'll display the others. A multimeter is used to measure the voltage or the current in a simple loop. For each figure, state whether the connection of the multimeter is correct or not. Then, if the connection is correct, specify the characteristic it reads. What does it read? Does it read voltage or current? Does it display positive or negative or what else? And in case it is connected in the wrong way, state what the error is. Okay, let's start with the first one. We have the circuit. The multimeter is used with the entries V and COM. So here it's used as a voltmeter. Voltmeters should be connected in parallel across the device. Otherwise, they form an open circuit and they read the voltage of the whole branch they are connected to. In this case, it's functioning as a voltmeter and it is connected in series. Notice that if you follow this circuit here, you reach this point and you go towards the voltmeter, which almost blocks the current. You know that voltmeters have very high resistance. So this is connected in the wrong way because it's connected in series. So here we have the multimeter. The multimeter is in the mode of a voltmeter, which we can write, by the way, as, between brackets, V mode. And thus, it should be connected in parallel across the device. Okay, across the load or the battery, regardless of whether it's the lamp or the battery. In this case, it's not. So it is connected in a wrong way. Okay? An alternative answer is to mention that it's connected in a wrong way, then you explain why. Why is it? Simply because it's not connected in parallel. If you want to be brief in your answers, it's okay. The main idea that you have to mention is that it is connected in a wrong way. Second, you have to mention that it's connected in a wrong way because it is not in parallel, it is in series. Okay? Writing it in a full sentence or simple sentences, same thing. Figure 2. Same question. Is it connected properly or not? Let's check. First, we try to specify the mode. What mode is the ammeter functioning with or the multimeter functioning with? COM and A. So using A and COM, then it is the A mode or ammeter mode. Okay, where it should be connected in series. Now let's check if it's in series or not. In the circuit, this is the positive. That's great. We go into the device, then continue out. So that's perfect. So it reads, thus, it reads properly. Now, we will add one thing. Does it read positive or negative value? Notice the entry or the positive pole here goes into the ammeter and goes towards what? The COM. And since the COM is connected, to the positive pole of the battery of the dry cell, then with an N, the ammeter or the multimeter, same thing, displays a negative reading. Okay? Now, before we move to the second part, first let me fix this. Okay. Before we move to the second part, maybe someone might stop and ask, why did you say it reads properly, then you said negative? Well, proper reading, yes, it will read. It is not gonna read, not gonna display some error or something like that. No, it will simply give a reading because it is functioning as an ammeter and it is connected as an ammeter should be connected. But over here, we have just misplaced the wires according to the battery. The ammeter still functions, but it's gonna give a negative value. If you are doing this in a lab session or in an experiment, all you have to do is just take the value وشيل الماينس sign. مش آخر الدنيا يعني. Okay? Moving on now. 3. Again, now we can go faster. Check mode. So the mode is VCOM or V mode, simply a voltmeter. It is connected in parallel. Connected in parallel across L, across the lamp. Not only that, COM is connected to the positive with the COM towards the positive of the dry cell. So, the multimeter is connected properly. The multimeter is connected properly. Okay? But it gives a negative reading of voltage of the lamp. Okay? An alternative answer here, and since you are in grade 9, guys, if you say that it's connected in a wrong way and it's connected improperly because the COM is connected to the positive pole, this is debatable. We can discuss it. A student of grade 9 might say that, but in principle, it is connected in the correct way. It's not wrong. No one mentioned that I want the voltmeter to give me precisely a positive value. It can give a negative value. It can still be counted for. So the connection is proper, is correct, but the reading is negative. Now, if the question states that we need to connect the voltmeter, as we have solved in one of the applications, in order to give a positive reading, then yes, this connection is wrong. Since there is no specification for the positive or negative or the polarity of the reading, okay, so this connection is proper and is correct. Okay? We proceed. Fourth part. Okay. The fourth part, again, the multimeter, but we are using now the A and the COM. So, mode, A mode, simply using A and COM, right? So it's functioning as an ammeter. Ammeters should be connected in series. Here, how is it connected? So connection is parallel. So what does that mean? It is connected in the wrong way. So this is a wrong connection because ammeters should be connected in series. Okay? In this device, in this circuit, the current is going to flow from the generator or the battery. It reaches this junction and it rushes towards the ammeter and continues. So here the ammeter is short-circuiting the lamp. So this is a wrong connection. Okay? That's it concerning exercise 2. In this exercise, we focused mainly on functioning and connection of the ammeter. I hope you got it. If not, go over it again and check what main ideas you missed. Now we go to a problem including many steps that we can solve together. Exercise 3. Let's take a look at the exercise, then we rush and solve it. A circuit consists of 3 lamps, L1, L2, and L3, which are connected in series across the terminals of a dry cell of voltage E equal 24. So the dry cell is delivering 24 volts. The lamps are in series. The circuit is protected by a switch K. A multimeter is used to measure the voltage of lamp L3, and it displays the value 6.0 volt. As in document 2, which is this one here, lamps L1 and L2 are identical. Lamps L1 and L2 are identical. Great. So that voltmeter or that multimeter is going to measure the voltage of the lamp, which is 6 volts. Switch K is closed. The current flowing in the circuit is given to be 0.3 ampere. Again, concerning using flow with current, it's not favorable, but it's fine. Okay, it's better to say the current in the circuit is. Okay, because current is the flow of. So we don't say the flow of something is flowing. Give the value of the current intensity across each of the 3 lamps. The voltage across the switch is 0. Why? Let's start solving them one by one. 3. Explain how it is possible to obtain a reading given by the multimeter. Okay, we'll proceed with that. On the second page, you're going to find the whole exercise but dissected. Okay? Take a look at it and let's move on. So, give the value of the current intensity across each of the 3 lamps. In order to answer that, always ask yourselves, first question, am I given the value of the current? If you are given the value, great. If not, the second question is, how is the circuit connected? Series or parallel? بيجي بطلع هون عندي current 0.3 ampere, which is flowing in the circuit عم بيقلنا. So in the whole circuit, the current is 0.3 ampere. And the circuit is connected in series where current is unique. So that's it. The current in the battery, in the switch, in the lamps is all 0.3 ampere. That's all we have to do. So 1.1, going to blue. So 1.1, part 1. We have the lamps. Okay. The lamps are connected in series, So directly, what can we say? So current intensity is unique. Okay? Meaning, 2 points, I1 equals I2 equals I3 equals 0.3 ampere. That's it. 2, I'll add it here. The voltage across the switch is 0. Why? 1.2. All you can say is the switch is closed. And that's more than enough. If you want further explanation, you can say it acts as a connecting wire. Okay? As a connecting wire. That's it. So this is concerning parts 1.1 and 1.2. Continuing to part 3, explain how it is possible to obtain the reading given by the multimeter. So the multimeter is going to give us a 6 volt reading, which is positive, right? and it's in volts, so it's a voltmeter. So how should we connect the multimeter? State the mode used, the outlets, and the connection of the terminals of the multimeter. This is something you should know. يعني هون بالسؤال محدد، لو مش محدد وعطاك مالتيميتر انت لازم تعرف انه لازم تحدد المود والكونكشنز واي فيش عم نستعمل، اي outlets عم نستعمل من الكوم AV. So 1.3, the multimeter functions as in V mode, between brackets, voltmeter. Okay? Now, what outlets do we use? Using V and COM outlets or inputs. Let me correct that. Okay, outlets or inputs. Simply input is the this terminal. Connection, connected in parallel across the device with COM closer to which pole? To the negative, which point is that? So if I want to connect it here, the negative is N, which is point N, Okay? Okay. And that's it. Are we given to draw the figure? We are not. So what I'm going to do is, I will add here figure. Okay? This is a further explanation. I'm not asked to draw a figure. I will add the figure just to understand or to match what I said with a drawing. So come towards the N point and V to the other side. Now definitely you can connect V anywhere between the lamp and this lamp, and you can connect the COM anywhere over here. Okay? Now, part 1.4. Determine the voltage across lamps L1 and L2, giving the necessary explanations. So what is the voltage across these lamps? Again, ask yourselves, am I given this value? In fact, not. I'm just given the 6 volt of the lamp L3. Second question is, how are these lamps connected? These lamps are in series, and we said that before. Now, how do we treat voltage in series connection? It is additive. So I'll add the voltages here, وبشوف شو بيصير عندي بعدين. Okay, so step 1, let's go to add voltages. Adding voltages تنعمل بطريقتين. We can either write voltage of the generator. So I'll write 1, 4. In series, voltage is additive. What does that mean? So, U generator equals U switch, UK, plus U of lamp 1, I will call it U1. Some people, as we said before, call it U of L1. Same thing. Plus U2, plus U3, and that's it. Now, voltage of the switch is 0. We mentioned that before. Voltage of lamp 3 is given. Voltage of generator is given to be 24. So 24 equals U1 plus U2 plus 6. So U1 plus U2 equals 24 minus 6, which is going to be 18 volt. So this is the voltage of 1 and 2 together. Am I given any further details concerning them? Because, you know, under this condition, each voltage can be any value which gives 18. 8, 10, 9, 9, 3, 15, 5, 13, I don't know. It can be any combination which gives 18 volts. But what are we given other than this? But lamps L1 and L2 are identical as given, right? That means, so voltage 1 equals voltage 2 equals 18 over 2, which is 9 volts. So each lamp takes 9 volts. Now, you can explain further here and say L1 and L2 are identical, therefore they take the same voltage and the same current. Okay? Now, being in series, they have the same current, which is something we do not need to argue about. Now, since we're interested with the voltages, to have the same voltage and add up to 18, each voltage should be 9 volts. Third part, okay, the multimeter, or fifth part in fact, has the ranges 2 volts, 10 volts, 12, 20, and 20. 20 and 100. Which range is the most convenient one to obtain the reading on the multimeter? Now, I do not have a lot of space, so I'll erase this and allow me to be a bit not neat, to write the answer on the top so that we have all answers together. 1, 5. Which range would you choose? The most convenient range or suitable range is the closest one to 6 volts yet and above it and larger than it. Okay? So the value is 2, 10, 12. The closest one to 6 yet larger than it is the 10. 2 is less. Okay, thus 10 volts is the best. Okay? All the other ranges, 12, 20, and 100 can work, but they are not the most convenient ones. Okay? We continue to finish the last two part, or the last part which is composed of 2 sections. Switch K now is opened. We open this switch. So if I want to draw the figure, I draw it again with an open switch. What is the intensity of the current in the circuit? When the switch is open, it stops the current from flowing in the whole branch. Don't forget, the current, as we said before, flows in the whole circuit as one unit. So if it's blocked here, then current cannot continue on this line, and definitely cannot continue to this line and the whole circuit. So what happens here is simply the whole current becomes 0. So what happens here? Part 2.1. What is the intensity of the current? 2.1. Okay. Open switch across the circuit. Okay, because the whole circuit is protected by the switch. Thus, I is 0 in the whole circuit. Okay? That's it. No more pathway for current to continue or for electrons to move, because electrons are opposite to current. 2.2. Give the values of the voltages of the switch and the lamps. Now, the lamps and the switch. We know that the switch takes the voltage of the whole circuit or the whole branch it is connected to. So, voltage of the switch is that of the generator, which is 24 volts. An open switch takes the voltage of its branch. And it is connected in the main branch, so it takes the voltage of the battery. Now, U1 equals U2 equals U3 equals to 0 volts, because the circuit is open. Open circuit. When the circuit is open, then current or electrons cannot move within the lamp, so the lamp cannot produce its own functioning, therefore no energy consumption or production of the lamps. That's why they have no voltage or no volts. Okay? That's all concerning this application, in which we went over series connection in all its details. The upcoming session, we're going to cover parallel connection. If you have any problems about this exercise, don't hesitate to ask about it, as we always say. Have a nice day.